All right, welcome everybody. Sorry about the technical challenges we were facing. A bit of a 11th hour transition, but we overcame, which is good. So, yeah, I thank all of you for taking the time out of your day to join us today. I want to introduce myself. My name is Tim Weaver, for those of you who don't know me, and I'm one of the co-founders of Diverso Energy. Diverso is a geothermal utility business operating here out of Toronto, Ontario. And today we want to talk about high density pencil buildings and geothermal. And I think this will be an interesting topic as, this is a segment of the market that's really been avoided for a long time, as long as I've been in the industry, almost 20 years. And I think, the reason for that is these projects are incredibly challenging. The buildings are tall, the sites are small. It's very difficult to achieve the heating and cooling requirements due to the size of the building and the size of the site. They're hard to get to. There's a long list of reasons why these types of projects have been avoided. But, now we're in 2024, and I think, the luxury of avoiding these projects has come and gone. And, although these buildings are a challenge, that doesn't change the fact that they are subject to the same very aggressive energy and carbon policies as every other building. So the luxury of avoiding them is no longer an option. And, although geothermal is a challenge and, the requirement for, extra know-how and experience is required, we believe that geothermal is still the best alternative. It's the best option to meet these new aggressive policies. It's the most cost-effective, the most efficient, and probably the most effective way to align with the new, and specifically in this case, the Toronto Green Standards. So, that's a good segue into the introduction to our panelists today. And I thought, rather than just talking about the possibility of this, let's talk to two individuals that are actually doing it. We've got Joseph Feldman from Camrost Felcorp. So Joseph is the Executive Vice President and Chief Operating Officer for Camrost Felcorp. Joseph has over 10 years of industry experience. He is a second-generation developer, taking over the family business. Joseph is responsible for overseeing developments within Camrost residential, commercial, and mixed-use portfolio, with expertise spanning the areas of planning, finance, construction, marketing, leasing, and sales. I think, I'll add to that. I've known Joseph a long time. Joseph is incredibly forward-thinking. He's innovative. He is willing to take a calculated risk, and he's proven that over the last, 7 to 8 years, as Camrost was one of Diverso's first clients, and they were willing to move forward when many others were not willing to. Bram, Atlin, Principal, Smith and Andersen. Anyone on this call in the GTA and in the development community will know Bram. He's become a bit of a household name in the multi-residential design community. And, Bram's known for a lot of things, but I think specifically he's known as a bit of a geothermal expert, specifically when it comes to integrating geothermal into more complex, complicated projects. And Bram's going to talk to us today about his experience, not only in geothermal, but specifically how do you make geothermal work in tall buildings where historically it was seen as not to be a viable option, and what are the tools and the tricks that he's learned to make that a possibility for his clients. So webinar goals, I think this webinar will probably take on a little bit of a life of its own, knowing the two panelists that we have today, and it's going to be a great conversation, great dialogue. But ultimately, we want to explore what does it take to actually achieve this new milestone, this new objective, to climb this mountain that 5-6 years ago was seen as an impossible mountain to climb. But we also want to be open and honest about the challenges that are faced. What are the things you need to overcome? What does a hybrid solution look like in this case? When is it needed? When is it not needed? And then just to kind of look at the long-term upside for the developer, whether it be a rental building or a condo, reduced operational costs, reduced CapEx, future-proofing, what are the reasons why you would do this? So Bram, we're going to start with you. I'm going to go through a couple of questions. So question one, what are the drivers for geothermal implementation in high-density pencil buildings? Why is this conversation now coming, why is it coming up now and not before?
Yeah, so you touched on one of the main drivers, which is local standards. In the case of Toronto, the Toronto Green Standard, but that'd be no different out in BC with the Vancouver bylaw and the BC Step Code and many other jurisdictions in the GTA that are slowly adopting different standards, and a lot of them will leapfrog, which I can talk about a little bit. They're not going to go from one step up. They're going to go elevate beyond the next version of TGS and try to get to where Toronto is. So that'll be a big step. So that's obviously the driver for that beyond pencil buildings, many residential buildings. On the pencil buildings specifically, so when we say, maybe we should define it a little bit, this super tall that has the 60 to 90, 100 stories that has a small footprint, and usually that small footprint has a really big core structurally. I won't talk too much about structural. And really what you end up in those is very little mechanical space at the top. So beyond the push for TGS, within the options you have to reduce carbon, a lot of them require significant space within the building, mostly at the top of the building. So we've seen this as an opportunity to address the TGS targets and not encumber the top of the building, or even, in some cases, it wouldn't even be possible. I have one example where we could not fit the partial air source heat pump plant at the top of the building. So this became a very viable option. And that's the uniqueness to the pencil building, but a lot of what I said is not unique to the implementation of geothermal in the GTA and other areas. There's also the benefit of going back specifically to pencil buildings, the fact that it's broken up into different chunks. So when you look at a 60 or 90 or 100-story building, you effectively address it mechanically as multiple individual buildings in terms of the pressure breaks and the systems you do. They can all be fed by one main system, but logistically, the distribution gets chunked up into different building types. And that presents unique opportunities to serve different parts of the building with different approaches, which we'll get into, I think, if we start to talk about hybrid buildings somewhere in here. So I'll save a bit of that teaser for later. Or
Yeah,
that's teaser for later.
And one thing that you actually didn't touch on, because in one of our applications in Mississauga, we were trying to figure out how do we get occupancy a little earlier. And we've been able to 60-story building or 66-story building, we can get occupancy because we don't need to finish the mechanical plant to the same extent as we would have otherwise without geothermal. So it's with these super talls, at the end of the project, you are fully drawn down on your loan. You have interest expense mounting up very quickly. You need to get occupied. It saved in this instance, it's going to save us a couple months.
Yeah, and that's a great point. That's actually an advantage we often talk about. So I'm glad you heard it from your side, from the development side. Now you can point to your sights on the elevator and the other critical path items, and not the mechanical system when you're rushing to finish up the building.
I think the benefits of geothermal are often put in categories of quantitative and qualitative. And I think as a developer, Joseph, it'd be pretty easy to actually quantify the monetary value of 2, 3, 4 months of early occupancy, right? So that probably will outweigh many of the other benefits.
Yeah, and outweigh some of the costs.
Yes.
And it's, yeah.
So, Bram, another question for you. What percentage of the buildings, or what percentage of the building does geothermal need to serve the TGS version 4 requirements? At what point is auxiliary equipment needed to bridge the gap? And I get it. That's a loaded question, but do your best.
Yeah. So the answer is depends. Next question. Oh, it is a bit of a loaded question. There's a lot of other factors. So, without diving into the details of TGS, it's an absolute metric based system. So, for example, if you do really amazing things on the envelope, if your project can afford an amazing envelope or a better envelope, that reduces the overall load. And by virtue of that, you would need less geothermal or less carbon reduction technology to meet the TGS targets. As a percentage of the total load, right? So The answer, without skirting it, the answer is, roughly speaking, with a bunch of assumptions that we normally take as true, you would need a plant that's around 40-50% electrified as a peak, and that would capture 70-80% of your annualized heating. Now, from a practical perspective, there's lots of geo jobs you do where it just makes a lot of sense for many other reasons that the geo system serves 100% of your HVAC heating and cooling loads. So I would say the majority of jobs we have under construction, well, the ones we have planned and are going through municipal approval are a little different because they may even do future versions of TGS, and there's other programs we can talk about. But the majority of geothermal jobs that are either occupied and operational or well under construction, it's the latter case that I described, where the geothermal system serves 100% of the HVAC heating and cooling loads. It can do some domestic, either passively or passively or actively, but by and large, the domestic hot water production in a big mixed-use residential is done differently or separately outside of the geo system. So,
yeah, and you raise a great point there. And just to clarify for some of the maybe lesser technical people on the call today, and also there's some Americans on the call, I believe, that are registered from New York. So our TGS refers to Toronto Green Standard, and if you are from New York, that would be equivalent to what you have as local law 97. But to Bram's point, this is an important thing to consider. Geothermal may address 40% of the peak load, and I think in our industry we often will over-index on the peak. So 40% of the peak, but Bram also mentioned that's equivalent to about 80% of the aggregate. And the aggregate is really the key number. That's the overall heating and cooling, which is really about the overall carbon reduction. So maybe we only get 40% of the holes in we would like to see to do 100% of the peak, but that 40% of the holes provides 80% of the aggregate, which is 80% of the carbon reduction, 80% of the energy reduction. And those are the metrics that these policies look at. They're less fussed about the peak, more concerned about the aggregate. So we're still within striking distance of 100% geothermal building, just with the fraction of the holes and boiler cooling tower to provide the remainder. Would that be a fair assessment, Bram?
Joseph, did you want to interrupt?
Well, it's just so interesting that the question's framed this way, because it looks like in Toronto, geothermal is becoming a household discussion amongst developers, and it's because of TGS V4. And TGS V4 is going to be very expensive to implement anyways, but it's crazy that geothermal, which makes sense without TGS, like we're out of Mississauga, we have no environmental standards. It's the right economic decision. It's probably the least costly, well, it is the least costly of any initiative that you need to do to meet V4. So it's just so interesting that Bram's probably getting phone calls off the hook from every developer client saying, hey, do I need to do geothermal to adhere to TGS V4? And what else do I need to do? What do I need to do with my glass? What do I need to do with the actual HVAC system within the building? What's going to be the least costly approach to adhering to it? And it's by far and away, it's a smart decision even without the standards in place. Like it's funny hearing discourse in the industry and even reading this question, because it's pushing geothermal forward, but it's TGS V4 is not what should have been the conduit to do that.
Yeah, I think you're not wrong, Joseph, but I think as the industry as a whole and society in general, you're an innovative person, but I think as a whole we respond to the stick, not the carrot. And I think what TGS has done is shifted from the carrot to the stick. So
it's a combination.
End up in the same place.
It's a combination of everything, and I use that example a lot that Joseph mentioned, that if I look at our portfolio projects and how many of them by percentage are geothermal, which is much higher than the average cross section of mixed use residential. A lot of those are outside of Toronto, so they're outside of what would be mandated by TGS. So the majority of them are in Toronto, but a good chunk, a meaningful chunk, is outside in Oakville, Mississauga, and a lot of surrounding areas.
But it's also probably because developers were doing it when they can cover 100% of heating, cooling loads for a building with geothermal instead of 40-50%. And based on the size of site that most Toronto sites, we're building on a postcard, like a tiny site, to hit 40-50%, it actually makes sense to still proceed with geothermal, but we never looked at it like that. Like in Mississauga, we have 2 buildings that are pretty much 100%. And the one building in Toronto that we were considering, we didn't do it 6 years ago, 70 years ago, because we couldn't hit the 100%. So now TGS is going to kind of change that thinking, because
well, I mean, bring it back to the pencil building, which is the question at hand. That's what made it very relevant. You are correct. Most of the jobs we looked at, it was all or nothing. It was 100% of HVAC loads or none. And there's some logic to that where that could be an option. But in Pennsylvania, I'm looking at an 80-something story building, and geo is the measure to hit the minimum version of TGS. We couldn't fit more boreholes in the site, but we happen to be able to fit what can hit the TGS target, so you don't have to do other things. It required, the alternative to that was 4 bus-sized air source heat pumps. So imagine putting 4 school buses on the top of a pencil building. So, that was the alternative, or slipping in VRF into a bunch of floors, which is not polar opposite from geothermal, as Joseph would probably point out.
We're doing the whole building in VRF, but
VRF geothermal, right?
All right, guys, I'm going to keep things moving along. Sorry, it's my job as the moderator. I think we're probably already 10 minutes behind, 10 minutes in, so
we'll make your job harder here.
Yeah, I think some of these questions are much, quick answers. So, Bram, please describe what a hybrid heating cooling system looks like.
Yeah, so it depends. But it's the way I want to answer this is that a hybrid can mean many different things. So we've been doing quote unquote hybrid for a long time in just very sneaky ways. So when we had a 100% geothermal building, but the load balance on aggregate, the annual load was a little off, we would do things like, let's take the air handling unit, off geo, or have the ability to do both geo or gas. So it's a bit of a lever to do an annualized balance. And to me, that's a form of hybrid. I think the true conventional way to think of hybrid is people think one part of your building is served by one piece and the other part of the building served by another, or the main system is a hybrid of different components, being geo and gas backup. So and in pencil buildings, it's going to have to look a lot different. So without getting into the details, hybrid can mean many, many, many things. And if you can do it, the trick, the one note I'd want to say on this is that it's really hard, it's really easy to make a complicated system, and it's really hard to do a simple system. And that's especially true on hybrid systems.
Yeah, so I think maybe to quick summarize that, what a hybrid looks like depends whether geothermal is doing 80% of the load or 40 or 50. If it's 40 or 50, you're going to need a cooling tower. If it's 80%, you may not need a cooling tower. It could be snow melt, dumping heat into the underground. There's alternative, more useful ways of addressing that gap, but at a certain point, a fluid cooler is required. Would that be That's a fair statement. We're getting more creative, and there's a lot of unique solutions that we've been discussing and implementing. Yeah. So I really like where the conversation's going on this topic. Yeah. So I'll let you be careful how you answer this one, but how would you categorize developers that are willing to adopt geothermal versus those that aren't? And why do you think that's happening?
There's many different things. Just taking a peek at the chat, I see there's one that points out the stigma among developers as it relates to what they're, providing the condo corp. So I think there's a bit of fear factor there in terms of doing something different than what they've always done, and what does that mean when they turn a building over? And I think that's one of the bigger hesitations. There's also there's just the unexplored. If they've never done it, you have a developer who's put up 10,000 units over their lifetime, and they've never done geothermal to shift to something they haven't done. I also would want to reframe this a bit and say it's almost more interesting to me on why different developers do geothermal. And we see that, there are the ones that want to save the planet, and I'm all for that, but there's also the ones that just see it purely from an economics perspective. It gives you advantages such as clearing up the penthouse space to use it for something else, or early occupancy, as Joseph mentioned. Avoided capital, all these different things. So they'll do it just in its own right. They couldn't care if it was, if it was sustainable or not. Although most of them are somewhere in the middle. If some, where it's a win-win-win. If they can do something that provides a benefit as it relates to climate change, sustainability, carbon, and it makes sense in the pro forma, and they might be able to market it, they would do that. And then there's others. I've been very curious about the other group, which is ones that do it because they know they'll eventually have to do it, and they don't want to do it when they're forced to do it. They want to test the waters now, understand it, make some mistakes with a little more breathing room, and then, not figure it out when it's a necessity.
Right. Why wait till there's a gun to your head when you can do it under your own terms? That makes sense. And we're definitely seeing the same thing. So for those developers who aren't there yet and are digging their heels in, what are the alternatives? So you're building a 70-story tower downtown. You applied for your SPA post version 4. What are the options? What advice to give clients who don't want to do geo?
Well, so there are alternatives, and sometimes due to the circumstances, those alternatives are very viable or the preferred or the lowest cost solution. So we can't shy away from that. In a lot of cases, geothermal is the lowest cost or most effective solution to achieving the goals of the project, one of them being greenhouse gas reduction. Generally speaking, the trend is really, I could really categorize it in 3 things, speaking about the focus on carbon reduction in the mixed-use residential sector. And it really is geothermal. Obviously, we're here talking about it today. It's central air source heat pumps. So, big, I don't know how technically you want me to get there, but central, very efficient electric boilers that run the heat pump circuit to do that, and VRF. And, just to give some quick examples, really the, mid-rise, low-rise buildings with a lot of available roof area, you might find that air source VRF is the lowest cost and a deep carbon reduction technology that meets all your goals. On the Pencil building, we already talked about that. Geo might be the only way to fit any carbon reduction in your building. It'd be below your building, right, to make that work. And then there's everything in between. But those are the 3. There are others coming out. We're seeing, they're all there, and I would brand them all under the category of different versions of air source, different versions of heat pump technology.
But I think, you've mentioned cost quite a bit. I think it has come up in every one of your answers. It's also important to recognize that in the GTA, the lion's share of the geothermal systems going in fall under that utility model, where the capital cost during construction is 0, whereas some of the other technologies, whether it be, triple pane punched windows, other heat pumps, air source, whatever the case may be, do not come with a utility model where you can shift that cost off balance sheet. As to Joseph's point earlier, trying to meet TGS is already expensive. And if you can address the lion's share of it with the technology that doesn't hit your balance sheet, that's also an advantage that geothermal brings, right? Because it's really an energy source utility, not a piece of equipment that ends up in your capital stack.
Yeah, we're seeing that the majority of our high-rise residential geothermal jobs are utility model.
Yeah,
or utility models.
All right, Joseph, you're up. So question 1, what inspired Camrost / you to become an early adopter of geothermal?
So we had a project in Leaside that we were not able to do our rinse and repeat, tried, tested, kind of 4-pipe fan coil heating cooling system in the building. And we met with a bunch of engineers, and as soon as we were flipping towards a VRF, water source VRF technology, that kind of, we started having to, we had to think a bit differently. And the building was like a cruise ship building. With VRF, we were able to plan. Actually, I think Bram actually provided some suggestions when we were going through the design of that building, and we didn't work with them. We didn't work with them. And from there, that kind of opened up that different way of thinking. And our engineer at the time was saying, you need to meet with Diverso because they do geothermal differently. And at that time, we had a lot of, there was a negative stigma amongst the entire industry on how are the condo corps going to handle it? It's going to delay construction significantly. When we met with Tim, we actually worked through a lot of this stuff. And the very next project, we did the water source VRF and paired it with geothermal. And I don't know if one of the later questions is going to get into it, but I think the biggest knock on geothermal is the stigma and how condo corps are going to working with them to having them understand the utility model. And then the number two is delays with construction, where everyone was coming to pitch us saying, yeah, you're going to dig a big hole and then we're going to monopolize that hole for 6 months as we drill, and you guys are just going to put everything on pause. You're going to incur interest expense, and yeah, your delivery is going to be 6 months out. And in working with Diverso, they looked at it differently. So it was really kind of quelling a lot of those concerns and solving for them that allowed us to introduce geothermal. And it was just kind of everything opportunistic. Like, it all happened at once, and we haven't looked back.
Well, I think, Joseph, for you too, correct me if I'm wrong, you're also of an age, and you're a real estate developer in Toronto, so you probably look 10 years older than you actually are, like everyone. But I'm sure you also grew up, your perception of sustainability might be different than someone 20 years your senior, correct?
It was not to go all political, but it was kind of we were indoctrinated in school. It was the topic of conversation that, whether it be my parents' generation, they didn't learn about it the same way with they call it David Suzuki and kind of every single school assembly. It was about climate change. And so I think my generation, it's hardwired in us to at least be conscious about it. And then there's also being a developer of 50 years of 50 years of existence. There was also the pragmatic approach that we had to get around, where we weren't going to break the bank and change the way we do everything and spend millions of dollars to start introducing greener technologies. Like, if I have a decision of, do we do this, which is not that expensive but will be better for the environment, I'll probably go that direction. But if it's a very expensive initiative, we're probably not going to do it if the numbers are not, if there's no semblance of a business case. So,
well, the bank will make that choice for you. So yeah, good. And this is about being open and honest. We can talk about all the merits of geothermal, and I always try my best to kind of lay out the pros and cons. And in most cases, the pros outweigh the cons. But let's talk about some of the challenges that developers should be aware of when installing geothermal, specifically in tall buildings. I think you're one of the few people who have done this. At Exchange, you were 60, 65 stories, 6 levels of underground, and we were there. It was not an easy process. I think we collaborated, linked arms, and did a great job of that, but there's a lot to be aware of, and maybe share with the participants what some of those challenges are.
So, not to promote Diverso, and you guys can read between the lines, but you are getting into a partnership with somebody that's not just, it's not a contract where you give them money and they do a simple service. This is a very complex system there's a lot of coordination, and you do need to work with a group that you trust, that are experts, actually understand the engineering around it. And then also understand, when we were doing our first building with Diverso, they had outsourced the drilling, and there were some challenges. They've since brought that in-house. So we have our in-house construction group. They have their in-house contractors, and there's a lot of trust with the geothermal installer, because again, there's two elements. There's the drilling at grade. So before we actually start our shoring and excavation, they need the site for 2 months. If it takes 3 months, that's bad for us. We're starting late. And so, and also if you don't have the design well in advance, then you're scrambling to get a design and they probably will start late. And you're already committed at that point. So that's risk factor one. You need to make sure they start in advance of when your shoring excavation is supposed to, and that they're actually going to adhere to their timeline, which so far Diverso has. Then when you're at the bottom of the pit, you've started spending money, you have your form worker lined up, ready to get going. They need 2 months at the bottom of the hole. That's the biggest cost to geothermal to us right now. We're lost time, and there's no way around it. But in terms of coordinating, like for EX3, we were able to dig. We were digging footings and working around Diverso in a cohesive manner to minimize that lost time at the bottom of the hole. So it's complex at that stage, and you need a lot of collaboration. But I mean, from a construction perspective, those are the two segments that really could burn you if you're not working with an experienced group. And I think we went through a lot of growing pains with Diverso, where Diverso in itself could probably, if a developer listens to them, could work with them and minimize that downtime. And with us, we're fortunate where our team actually has experience in coordinating with Diverso. And the second part of it is on the back end, when the system's actually up and running. And once you get past the stigma of what happens if the geofield fails, which you see the smirk on Bram's face, because he's probably taken that question a billion times. And if you understand the science around it, you could understand how ridiculous that comment is. But there's also the stigma of, wait, I have a fixed fee for the next 30 years as a condo corp. The condo corps are like, what? That's crazy. And if you start explaining to them and actually take the time to get them to understand that rather than be tied to commodity costs being gas, water, electricity, which historically they've gone up, this is a fixed fee with fixed escalations. There's no, I guess, commodity type interferences that will take hold of a condo corp's budget. And if you ask the simple question of what are the chances utility costs go down over the next 30 years, you'll get a little bit of a smile from the other person on the condo corp saying, yeah, you're right. Okay, I get it. And it's the same thing we're going through where we now do bulk internet with Rogers or Bell in all our buildings. It's always met with a little bit of abrasiveness. Oh, you're committing me to Rogers or Bell. And then you could, well, yeah, $25 instead of doing a $100 internet package. It's the same thing with geothermal, where it is the smart utility model in the moving forward. And it does take, there is a stigma, and it still is a discussion with condo boards that if we just did a rinse and repeat building, you wouldn't have. But it's not that difficult to explain to them. And at some point it will become almost an expectation, I believe. So you won't have the same back and forth. So.
Oh, that's a great point. And I think geothermal gets lumped in the category of a feel-good, sustainable technology. But when you're doing a 60, 70-story building and the rubber hits the road, it's no longer about sustainability. It's now about coordination, sequencing, workflow. It's construction. It's no different than forming or anything else. It's got to be in the Gantt chart. Everyone's working together. PMs, site supers, coordination is key. And that sometimes, people don't want to talk about that because it's kind of uninteresting and very detail oriented, but without it, the chance of success is very low. So,
and I look forward to talking to a lot of like the president of the condo board 15 years from now, where he hears of cooling tower having to be replaced on another building, yet they have a geofield underneath and they're just paying their fee. The maintenance is being done by Diverso, and they're like, wow, like that was a good decision. I mean, we're not building for the immediate. We're like, we really at Camrost do have a long-term outlook where we do want to be relevant, not just today, but 50 years from now. So,
right. Cost variable versus cost certainty. I think that's an easy choice.
Yeah, it'd also be an interesting conversation 15 years from now if there's any enforcement on the mandatory reporting of buildings. So if you built an energy pig with natural gas today and they get taxed later in a different mechanism because, they didn't do the right things, they'll be paying for it later. But, I take this question, and I know we're going to move on to the next question, but I'm going to go back to my answer before, which is there's a lot of issues with tall buildings. They need to be designed right. And the system's already complicated, and you make it more complicated. You really need the right design team, here comes shameless plug, to make it work and be seamless and really go smoothly.
Yeah, and those are two very different exercises. There's the design coordination with Smith and Andersen on how are we doing this hybrid? Are we utilizing snow melt, and what is that interface between the geothermal and the mechanical? Because it's a very symbiotic relationship. But then in parallel to that is us and the construction manager, and how do we interact with shoring and excavating and forming and timelines and everything else? So it's an incredibly complex and nuanced conversation that, back to my comment earlier, tall buildings are tricky, and as much as it does require an extra level of know-how and an extra level of experience, I think to Joseph's point, it still does make the most sense in most circumstances. So here's just a quick glimpse at when Joseph referenced the exchange. This is their project in Mississauga, right next to Square One. Obviously, beautiful development, and both those towers are 100% geothermal, and they are the tallest fully geothermal buildings in North America. And we were able to do that because the size of the site and getting pretty creative, we were able to make that work. But
I guess this is a good example of hybrid. We did 2 of the 4 buildings based on the size of the development. So the blue top building, and then the building in the front right. So EX3 and EXS.
Yep. So Joseph, just to be conscious of time, we have about 10 minutes, and we have a lot of questions coming in, so we can get through these as quick as possible and try to tackle as many questions as we can, and stay within that hour and 5-minute time period. So you mentioned earlier water source VRF. Maybe you just quick talk through, because I think there's a bit of a stigma that or a misconception, geothermal equals packaged heat pumps. And yes, that's true. The lion's share of our projects are packaged heat pumps, distributed heat pumps, but in your case, you're almost exclusively water source VRF. Why is that?
We had a lot of success with it in our Leaside development, which is this cruise ship building. I could delve into why we did it on that building. And just after overcoming the biggest problem with water source VRF, which is refrigerant trades, after realizing, wait a second, there is a refrigerant sector that's being built up in the city of Toronto on a residential setting, we felt comfortable that we'd get competitive numbers, and this is our standard moving forward. I'm a big fan of water source VRF. So it's also, I believe, the perfect pair with geothermal, but
if I can interject, it's actually and by the way, Joseph and I didn't do this build, it's his building, and we actually haven't worked together quite a bit yet, so you're getting independent opinions. But water source VRF, there's a very interesting history there, that it was really popular for a short period of time. Then we saw a drop in popularity, and most of that drop in popularity was because the back end heat input was gas boilers. And then, we Smith and Andersen on the res side have always been saying, well, if you could just pair that with geothermal, it'd be this perfect pairing. So it's really refreshing to hear it on the development side, that you found you came to that same conclusion.
But the biggest Tridel and ourselves were really the first to do it in the water source VRF in a high-rise setting. And we both had similar buildings. They had this tiered building on the waterfront, and we had a tiered building in Leaside. So there were design reasons to use the system, but the biggest problem at the time was availability of refrigerant trades. So that's being resolved, and we have some great refrigerant trades now.
Great. So I think number 2, you've already answered, what gave you the confidence? You've covered
Diverso.
That. Okay, thank you. Number 3 on this screen, supplementary benefits. So what are the kind of auxiliary benefits to adopting geothermal other than the obvious, meeting, green policy, getting equipment off the roof? I think, like, have you experienced, maybe not so much on your exchange, but on some of the smaller geothermal projects that you're doing, is there additional rooftop amenity space? Is there leverage you have with the city when you're negotiating density? Or what are some of the other, maybe less obvious benefits of implementing geothermal?
So we've actually been very quiet in our adoption of geothermal. So we have not been trading it with the city. We have not actually yet used it because of TGS. So in terms of city benefits, we have not seen any, but now being tried, tested, and true for us. So I do think we can get benefits in this by committing it to it in the future in rezoning sites and doing rooftop amenities, which we have a building that we will be coming to market probably in 2025 that will have a rooftop amenity because of geothermal. But I mean, on the cost side of things, it's if you can overcome the additional construction costs and construction related risks and timeline related risks, which it is possible. It is nice that we are saving on some capital costs where there is equipment that we can eliminate. It's nice for the condo corp that there is cost certainty moving forward where they're not tied to commodity pricing, the buildings less so. And the occupancy thing, I think as buildings, there are more super talls coming. There that anecdote that I provided earlier where, funny enough, the red top building in the background is not geothermal, but we will be using the geothermal of the shorter building to occupy the lower half of the red top building. So we've just been able to be creative, and it's saving us millions in interest expense.
Yeah,
millions. So it's yeah, I mean, if you understand basic understanding of the system, you work with smart engineers, you can figure out ways to really see additional benefits that are outside of the obvious. So
yeah, and that type of that exact example is something that we've been pushing quite a bit in called the business as usual, prior to geothermal seeing an adoption, and geothermal is just giving us the ability to do the same thing more elegantly. What I mean by that is we've always been promoting plants on the lower tower that could serve your taller tower and get early occupancies, but it required a physical plant with boiler flues and cooling tower openings on the lower plant that had a visual issue and all that. And now you might be able to achieve that with geothermal. And just to put a bit of a cap on what you were talking about before, we have been involved in jobs where geothermal has been a political strategy to gain access to that space at the top of the building. So we had a job that was zoned. It happened to be zoned uniquely where it was total mass of the building. It wasn't described as, top floor, 66 floors plus penthouse. It was saying your building shall be this tall and this big and not cast a shadow on that. And
with the right way of doing things,
the right way, and it's rare, it's the exception, not the rule. And geothermal allowed them to put suites at the top. So, that's an example of where you did see that benefit.
Yeah, and I think, Bram, you and I are both working on projects where we know geothermal is being used as a form of horse trading with the city. And in many cases now, we're actually seeing the city using it as leverage to convince developers, you put in geothermal and we'll work with you on your density requests. And I find that fascinating. It wasn't that long ago we were trying to educate municipalities on what geothermal is, and now here we are. They're using it as a chip in their
I think
pocket.
that's so backwards. Height and density based on it's so backwards, and especially in the midst of
that's a
crisis.
We could do a webinar, I think, on that alone.
Oh my God.
I think we're just playing in the sandbox we were put in, but no one's going to disagree.
Yeah, I don't have to agree with something to accept it. So I think we have 11 questions right now. I want to try to leave some time. I think if we can answer this question as quickly as possible, Joseph, and see if we can get into some of the actual questions in the chat, that would be great. And I think you've mostly
Yeah, I mean,
answered this, and I think you've articulated very clearly your stance on, you know, what are the challenges and why should you do it and why have you done it? So
honestly, again, not to promote Diverso a little, there are other geothermal providers. If you are determining which one to work with, actually understand who's doing the engineering. In terms of the financial modeling, is this going to be, is who's the financial backer? Is there green financing behind it? Are they trying to gouge, or are they literally just trying to do good and have a long-term sustainable business? And then who's doing the construction? Because realistically, it's the fee that is of concern in the long term. You can get hit if the fee is too high. It's the engineering and it actually making good and getting the maximum out of the site in order for the economics to work. And I think the biggest risk factor is construction. And I mean, Diverso tends to check all three boxes, and they do construction in-house. They probably have one of the best engineers in North America that is in Toronto, understanding Toronto soil conditions, like, which is a big game changer. And lastly, they're so fair when it comes to the fee, so fair, and they work with you and provide you the analysis you need in order to justify the long-term decision. And like, they'll use today's utility rates in the justification. And quite frankly, gas prices are probably going way higher than they project, but yet it still works at today's numbers. So there's not any games being played in their financial analysis, whereby I have seen others in the industry kind of jack up gas prices in order to justify their fee. And yeah, you do need to work with the right group. And if it's an experienced group with an experienced engineer involved, they'll help you get through it. So it's really not rocket science. It's a bunch of holes in the earth and piping and pumps.
I appreciate those kind words, Joseph. And I think, you know, the utility model as a whole is a bit of a game changer, because now it's about skin in the game and accountability. If you work with a company who's investing $2, $3, $4 billion in your project, it's buried under the building. They don't get it back unless the system performs for the next 30 years. That shifts the accountability. It shifts the conversation completely. This isn't, you know, for those contractors on the call, rather than a 10% holdback over 12 months, imagine 100% holdback spread out over 30 years. So it shifts the accountability, and now there's a contractual and financial obligation. And I think that's there as a peace of mind for you as a developer when your reputation is everything. Is, can you bring the risk to zero, to Joseph's point? No. But under the right circumstances, I think that risk can get to that threshold where the benefits outweigh the risk. And, you know, that's what, as an industry, we're trying to do. I think you can answer this one quickly, and then we're going to dive into some questions.
I mean, that's a loaded question. I'd like to say all, but some sites don't make sense where we're not eliminating enough equipment, and it doesn't make sense for the at this point, unless there's tons of subsidies thrown at that may or may not make sense. So as many as possible, but again, only when it does make financial sense. And we are very pragmatic. We're not looking to have a short-term game by virtue signaling, saying we're doing geothermal. We're looking at the long term here, and if it's the right decision for the building, I know Bram will say every building we can make it the right decision, but looking at the actual pro forma and the numbers is what drives. And we have a postcard stamped site that is, I think it's sub 10,000 square feet, the whole site area. I don't think we're going to be doing geothermal there, especially because of the construction delays that it would cause. But as much as possible where it makes financial sense.
Yeah, that's a very fair and reasonable answer. And I agree with you. We see projects all the time where I'll actually make a suggestion for air source heat pumps. It's just, you can tell based on maybe it's geology, size of the building. There's a lot of factors, and geothermal is a big decision, and you don't take that decision lightly. So all the boxes, or at least most of them, need to be checked. in order to move forward. So.
I'll take a crack at this one just because it probably gives a perspective beyond Joseph's portfolio. So mine would be a cross section across many developers, many sites, many areas, and you know, I would say going back 5 years ago, 10-20%, you know, 2 in 10, 1 in 10 were geothermal. And if I go, you know, 5 years ago, it's 30%, and it's growing. Like, I mean, the way I would say it now is it's still not 80%, but every single job we work on now is having a meaningful discussion. It's not just something that's brought up. You know, 5 years ago it was brought up on every building, but it was not brought up seriously. And even, you know, in the last few years, it's brought up seriously on every single building, and it's almost table stakes. Are we doing geo, or are we doing air source heat pumps, or are we doing something else? Right.
And wait until the cost consultants start telling developers in Toronto, like TGS tier version 4 is going to add so much to the cost of construction. It's really, it's going to be a very expensive piece of legislation coming in. As soon as you realize how cost neutral geothermal is, and the how big a punch it packs in adhering to those targets, and how much money it'll save, I think that's where a lot of cost consultants are going to start pointing to developers and, hey, I know there's been reluctance, go for it, because on this side you should be doing it.
And what I'll add to that's true, and the utility model for sure is what you'd be referencing there. But the other angle to this, which has been really interesting, a change which answers this question a little, is we're seeing less of what I'll brand as the I don't know tax. So we're, you know, when I was doing my first residential geothermal job, we thought we would save $250,000 in equipment or a bit more, and we saved zero. And that was just the first one. And that's because a big residential mechanical contractor said, this is complicated. I got to insulate risers. I didn't have to insulate, like little things, but they became big deals because they didn't know. And we're not hearing that today. We're actually seeing a good chunk of reputable volume-based mechanical contractors saying, yeah, it's simple. I don't have to be yelled at when I'm at the top of the building to tie in a cooling tower. I don't have to, you know, it's really simple. They just had to get their minds around it. And I think that also that's a qualitative response, but I do believe it's quantitative in their pricing.
And also in the I don't know tax, I mean, the first building we did was a purpose-built rental, and we were maintaining long-term ownership. So we actually bought the geofield and thought this is going to help us in the long term. We were able to get through a lot of the construction-related I don't knows. Like, actually, a question for you, Tim. In terms of the PCLs, Elistons, SkyGrids, Birds, Tuckers, how many of them are you working with? Because after they have 1 or 2 of these under their belt, they're deemed, like, we construct in-house. I'd consider us able to install one of these systems and work with you.
Yeah.
After they do 1 or 2, they probably are in the same boat.
Yeah, no, more or less. I think, you know, that's a tough one because, like developers, construction managers, you know, there's both ends of those bookends. But I think some of the larger firms like a SkyGrid, Multiplex, you know, they're professional firms. They know this is coming. They know they need to adopt it. They may not necessarily be there by choice, but once we go through a project, just like you as a developer, and they realize, okay, this is no different than anything else. Insert it in our Gantt chart in the right place, coordinate with the Diverso team. It's just another piece of the construction. It's no more complicated than putting in a bathtub raft slab or footings or anything else. And, you know, we're not seeing near the resistance that we were 5 or 6 years ago. So I've got to move to, we've got a poll question we want to ask. What is the biggest challenge you foresee in achieving 100% electrification? Actually, I think I'm going to rephrase that question just to be more clear. What is the challenge in foreseeing or in achieving 100% electrification on new multi-residential buildings? This isn't meant, you know, cars, industrial buildings, community centers. You know, over the next 5 to 6 years, a lot of municipalities are aggressively pushing for all buildings to be net zero, you know, kind of snip the gas line type approach. So we're looking for an audience poll on, you know, what do you think is the biggest challenge based on these 3 options? Is it retrofitting? our current building stock? Is it limitation of off-site technology or on-site technology that should read, or is it the impact on current electrical infrastructure? So to electrify new buildings, actually, as well as existing buildings, what is the biggest challenge? Is it the infrastructure, the grid? Is it limitations on technology? Heat pumps aren't there yet. Makeup air is not there yet. Domestic hot water heaters aren't there yet. Or is it the biggest challenge figuring out how to retrofit, drill holes underneath existing buildings? Which do you think is the most significant of those three challenges? All right, I'm going to stop sharing and get into some of the questions. All right, so let's read through some of these. What is the thermal range you're going after with respect to the geothermal resource, and how deep have you been drilling to date? So I can tackle that one. That's pretty straightforward. Our holes, you're anywhere from 600 to 800 feet. 600 if we're drilling in shale and we don't have to, there's not a lot of overburden, not a lot of casing. 800 feet if there's more casing. Thermal range, we're a little bit different in this regard. We have a couple dozen buildings operating, and we know that multi-residential buildings in Toronto are cooling dominant. And so it's more about getting rid of heat than adding heat. And most of our bore fields are operating between 48 degrees, which is about as low as we'd go in the winter, up to about 85 in the summer. So a mechanical engineer like Bram can, with confidence, design a distribution system around that kind of operating temperature range. So there's still this is a good question. There's still a huge stigma amongst developers that we have worked with about using geothermal on a condominium. What are we doing to satisfy their concerns about the condo corp? And I think, Joseph, you touched on a lot of this earlier, and I'll take a quick stab at this, and I'd like to hear your perspective because we've now transitioned lots of buildings over. One of the things that we do is get out in front of it. Like anything, it's conversation. So we insist on meeting that condo corp at time of transfer, and it's almost selling it all over again. And we'll say, listen, Camrost did the right thing here. This wasn't easy for them, and they did you guys a favor because you no longer have a cooling tower you need to manage. You don't have to carry a capital reserve for that cooling tower when you're doing your reserve fund study. You don't have to crane new boilers on the roof in 20 years. You don't have to hire specialized trades to maintain and manage that cooling tower and those heating boilers. If you look at New York, local law 97 was dropped in everyone's lap. A lot of buildings now need to go through a deep retrofit to comply with the policy that no one knew existed 5 years ago. So that condo corp is now, you've mitigated their risk on future policies, cost certainty, simplicity, budgeting simplicity. So go through all that. And what we've found is they recognize, yeah, this is an amazing decision. I'm glad it's in the building. And as Joseph's point, as long as the contract is fair, there's a performance guarantee and the pricing is fair, we see very little pushback.
Yeah, I mean, we're going through a big wave with bulk internet. And it's a matter of just getting ahead of it and explaining the financial benefits to the condo corp and the simplicity of the technology. And it's the same with any change that we experience where you're trying to be leading edge and do something good. But again, we also take the outlook of what will be best for the condo corp moving forward. That's one of our decision making metrics. So we just share kind of why did we make this decision for you to benefit you, and it's all about communication, because the worst thing you can do is do it and then not tell them about it and have them talk in their board meetings and have this kind of circular pitchfork ups, developers are evil, and you want to avoid that. So
yeah, no one said disclosure in the APS. and promotion and make sure, you know, it was clear.
That goes without
Yeah, that goes
saying.
without saying, but
Yeah,
Our
definitely.
condo
I
dogs.
always, you know, it's something that it comes up. Because this isn't new. Like you give a great example on communications. Like how's it different than a utility, you know, a private utility provider such as communications, the Rogers and Bell. And it might not be different than in the downtown core or in downtown Vancouver with central utility plants that do feed buildings. And it's a very similar agreement in part of its concept. So it's not a new thing, and I think it's disclosure and all the things you mentioned.
We also do use it in our marketing because, I mean, Tim doubted my approach up front, where now he's a big advocate for it. So if you want any developer out there to want to talk to Tim about how can this be effectively marketed, he went through the ride with us, and I think we found an effective way where for EX3 in particular and EXS out in Mississauga, it was one of many marketing messages that were front and center. So they can't really complain about it if they bought in a building that we fully disclosed and marketed that we were doing this.
I'll never doubt you again, Joseph. How does geothermal drilling affect the critical path of building construction? I can answer that one pretty quickly. I think now almost all of the municipalities in Southern Ontario have some form of a geothermal drilling permit. Toronto specific, they kind of started that trend, which is really good. It's a quick turnaround. So what that allows us to do is drill in advance. We roll into site, drill the holes. The holes are they're plugged, they're capped, they're countersunk. So essentially our entire infrastructure is drilled pre-shoring, pre-excavating, terminated below final grade. So that allows the entire infrastructure to go in kind of in advance of your critical path. So the critical path really starts when you start shoring and excavating. Now, the caveat there, if there's demo, we're in between demo and shoring and excavating, nothing we can do about that. And then I think the real impact, to Joseph's point, is when you're down in the pit. And that's where, you know, having the right team, get that tie-in done as quickly as possible, coordination, sequencing, we work within the pour breaks. So there might be a 2 to 3 week delay at the beginning where we do that. We have to do our tie-in underneath pour break number 1. But at that point, we're now tying in pour break 2 while you're pouring 1, and essentially forming contractors chasing us around the site. So
realistically though, 2 to 3 weeks it's a month. If you budget for a month, you'll be pleased if you work with the right group.
Yeah. Now we've also vertically integrated and have our own tie-in. So I'm going to say that 4 weeks is now 2 to 3 weeks, but
you'll prove us wrong on Raglan.
So this is more of a comment. This is for you, Joseph, probably for both of you. We need bankers of a younger generation too. So,
you know, I have to give the banking industry a lot of credit. I mean, we were doing a quick chat, Bram, Tim, myself, on Monday, and there's now green mortgages that are being introduced at a consumer level. I don't know how many of them have been given out, but that I do think that that's coming forward. Capital Developments and National Bank just announced a green loan, and with Olive up in North York. And I think that I'm not familiar with the terms, but I've asked where
Smith and Andersen building.
Yeah, that's a Smith and Andersen. Actually, you're closer to it than I am, but there is a lot of, and then with MLS Select and purpose-built rental, where I don't think it bridges the gap to get more purpose-built built and help the financials, but it's a step in the right direction where there is longer M and more attractive rates using CMHC financing to get purpose-built built. And geothermal is again one of the easiest ways to qualify for any of those programs.
So just to kind of keep things moving along, sorry, Joseph, there's some really good questions here. So I'm going to just kind of go through these really quickly. It's 2:08, so with respect for everyone's time. If you rely on snow melt, how do you deal with a warmer winter without much snow? That's
I can answer that one.
Go ahead.
Yeah. The nuance we didn't talk about is that we're actually talking about a creative solution to use snow melt as heat rejection, potentially even in summertime. So we weren't talking about active snow melt when it's snowing. So kind of just like we'd have to do a technical deep dive to really explain that, but it was one of our tricks, as well as aggregate load in the wintertime. So it's a complicated answer if you really want to dive into it.
which we're doing for EX3.
So bathtub raft slabs. So this comes up a lot, especially in Toronto over the last year and a half, since no longer have access to dewatering permits. Probably more than half of our projects are bathtub raft slabs. So bathtub raft slabs is basically, instead of traditional spread footings or piles, it's a giant slab and it's waterproof. We obviously don't want to penetrate that slab. So what we do instead is all those horizontal tines are below the raft, rather than coming through the raft and doing it in that interstitial space between the raft and the slab. It's done underneath the raft, and it's coming up. Our supply and return lines would come up the outside of the building between the caisson wall and the foundation wall. And then we don't actually penetrate the waterproofing until P1, which gets us up either, ideally above the water table, or, worst case scenario, it might still be in the water table, but the static pressure is much lower. And it's one single controlled entry point into a mechanical room, as opposed to 100 penetrations through a bathtub raft slab. So that's a pretty straightforward way of dealing with that. And it is becoming, pretty common and not really that big of a deal anymore. But it was definitely a concern until that solution was sort of ironed out, just to make sure there is no compromising of that waterproofing. So I think Tim's response, are those temperatures Celsius or Fahrenheit? Oh, sorry. Yeah. My temperatures are Fahrenheit, 48 degrees Fahrenheit to 100, to about 90, 85, 80 degrees Fahrenheit is the operating range. And one last question here. So in certain sites, we may see the range around freezing point. Okay, utilize geothermal for winter heating as well. So I think the question around the limitations of geothermal and temperature, we've got geothermal systems in Winnipeg. And in my previous life, I was doing a lot of geothermal across the northeastern United States. We did geothermal, Thunder Bay. We did a school up there. There really is no limitation. It's about the energy needs of the building, because keep in mind, geothermal is buried 100, 200, 300, 500, 600 feet underground. It has no idea if it's -40 or -5. So it's really more about that annual balance between heating and cooling. And if there's a significant imbalance, how do you address that? Is it injecting some additional heat into the building to offset the geothermal in the winter? Or is it rejecting a little bit of excess heat to offset that imbalance in the summer if it's cooling dominant? So it's really more about managing that imbalance than it is the actual extreme temperatures between heating and cooling. So I think that pretty much covers the questions. It's 2:12, and I appreciate for all of those you who stuck around. Joseph, Bram, thank you so much for joining us. Those were great answers, great dialogue. I really appreciate you sharing all of your experience with everyone who chimed in, and appreciate everyone for joining. Thank you.
Thank you.
Thank you for arranging this.
Yeah, our pleasure. Thank you, guys. Take care, everyone. Have a great day.